We are continuing our chapter on geometry. In this section, we're going to look at right triangle trigonometry. The objectives are to use the lengths of the sides of a right triangle to find trigonometric ratios, use trigonometric ratios to find missing parts of right triangles, and use trigonometric ratios to solve applied problems. Trigonometry means measurement of triangles. And we're going to look at trigonometric ratios. To do this, we let A represent an acute angle of a right triangle. The right triangle is C. This is shown in the diagram below. So the angle is indicated by a capital letter. The side opposite that angle is denoted by the corresponding lowercase letter. Small a corresponds to angle A. Small b is opposite angle B. Small c, the hypotenuse, is opposite angle C, the right angle. For angle A, the trigonometric ratios are defined as follows. The sine of A is the side opposite angle A over the hypotenuse, or A over C. The cosine of A is the side adjacent to angle A over the hypotenuse, so that would be B over C. And the tangent of A is the side opposite the angle A over the side adjacent to the angle A, which would be A over B. You can find the same ratios for angle B. Example 1, becoming familiar with the trigonometric ratios. Find the sine, cosine, and tangent of A. For the solution, we use the Pythagorean theorem to find the measure of hypotenuse C. We are given the two legs, 12 and 5 units in length. So solving for C using the Pythagorean theorem, we get that C is equal to 13 units. We label our triangle. And now we have numbers that we can associate with the sine, cosine, and tangent. The sine of angle A is the side opposite angle A, which is 5, over the hypotenuse, 13. Cosine is the side adjacent to angle A, which is one of its sides, basically, and that is 12 over 13. Tangent A is the side opposite angle A, which is 5, over the side adjacent to angle A, which is 12. Example 2 is finding a missing leg of a right triangle. We want to find the measurement of A in this right triangle. Remember that the right angle is denoted by a little square at the vertex. Solution. We have a known angle, 40 degrees. We have a known tangent ratio and an unknown side, A, and a known adjacent side, 150. So because of what we know, we are going to select the tangent ratio because it involves the side that we're trying to find the measure of and the side that we already know. That's why we use the tangent for this particular problem. So the tangent of 40 degrees is equal to A over 150. Solving for A, we're multiplying both sides by 150. So we have A is equal to 150 tangent 40 degrees. And if you have a scientific calculator, or you can use your calculator on your cell phone by turning the calculator in landscape mode, we would multiply 150 by the value of the tangent of 40 degrees and get approximately 126 centimeters. Trig has a lot of applications. We can look at the angle of elevation, which per the diagram to the right, you see is the angle formed by a horizontal line, and the line of sight to an object that is above the horizontal line. The angle of depression is the angle formed by a horizontal line and a line of sight to an object that is below the horizontal line. Example 2 is a problem solving using an angle of elevation. We want to find the approximate height of this tower, and we don't want to climb the tower, but we can use what we know about trig to find the approximate height. We have a right triangle because the tower is assumed to be perpendicular to the ground. The angle to the top is 57.2 degrees, and the known adjacent side, the measure from the tower to where we stand, is equal to 125 feet. Again, we happen to be using the tangent ratio because we want to find A. We have the measure of the angle opposite A, and we have the measure of the adjacent side. So in this case, we'll use tangent. For some problems, you'll use one of the other trigonometric ratios. Doing like we did before, we are going to substitute our numbers in, and solving for A, we get approximately 194 feet without climbing the tower. In this example, example 4, we're determining the angle of elevation. So we have a building that we know is 21 meters tall. It casts a shadow 25 meters long. Refer to the diagram. If you don't have a diagram, you can always draw one. We want to find the angle of elevation of the sun. So we're asked to find the measure of angle A as it has been marked in this figure. Again, this happens to be using tangent. The tangent of the angle A involves the side opposite A, which is the 25 meters. Excuse me, the side opposite A, not adjacent to. The side opposite A is 21 meters. The side adjacent to A is 25 meters. So tangent of A is 21 over 25. To find this, we can use the inverse tangent key, and this shows you what keys to press if you're using a lot of the scientific calculators or using some of the graphing calculators. You can refer to your instructions for your specific calculator for instructions. But when we follow the keystrokes, we find that the display is approximately 40. So that means that the angle of elevation of the sun is approximately 40 degrees. And that concludes this lesson.